Hello everybody, getting ready to do lesson 5.3 of Geometry 1 Math, Part 1, Part 2, Part 3. Email me there. 5.3, proving triangles are congruent using ASA and AAS. And we have a skill sheet, classwork sheet 34, points and 0 points in note taking. Teachers, here is your bell work for the day. And we have using a diagram, corresponding alternate interior, same side interior, angle 9, angle 4, and determine whether this is a triangle. Give your students 4 minutes for this. Okay, welcome back. Corresponding angles, angle 9 and angle 4, 9 and 4, they're corresponding. And then no, 16 plus 14 is not greater than 30. This cannot be a triangle. Postulate 14, angle side angle congruence. If two angles included side of one triangle are congruent to two angles included side of a second, then the two triangles are congruent. Here's an example here, angle side angle. And then this would be angle side angle here. So angle A and D, side ACDF, angle C and F, then triangle ABC is congruent to DEF, angle side angle. Okay, first got to practice complete statement. You can use ASA congruence postulate when the congruent sides are blank between the corresponding congruent angles. Missing information, determine what congruence is needed in order to use the indicated postulate or theorem to show that triangles are congruent. Students, ASA congruence postulate. So what's missing here for that postulate with these two triangles, students? Okay, for number 2 would be AC has to be congruent with FD. This is the missing side here, and then FD, FD, and then AC. These would have to be congruent. And then up here, number 1, you can use ASA when the corresponding sides are included between the corresponding angles. Included. Okay, theorem 5.1, angle side. If two angles in the non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second, then the two triangles are congruent. Here's an example here, angle side, angle side, angle side here. So if you got those conditions going on, angle A, angle D, angle C, angle F, and B, C, and EF, then these two triangles will be congruent to each other. Example 2, what additional congruence is needed to show that JKL is congruent to NML by the AAS congruence theorem. So you're given KL is congruent to ML, KL and ML, because angle KLJ and MLN are verticals. We know that these two angles here are congruent. The angles that make KL and ML the non-included sides are angle J and angle N. So angle J and angle N. So you need to know that angle J is congruent to angle N. That's what you need in this situation here for angle side. We got this B angle, then we need one more angle. Then we know these sides, so that's what we need. Okay, what congruence do you need to know in order to use the indicated postulate or theorem? Same thing down here, students, for yours. Angle side congruence theorem. Teachers, give your students 5 minutes. Welcome back. So we need to know angle A is congruent to angle D. Angle A is congruent with angle D. That'd be angle side. And then see angle A here, angle A. So be angle side here too. And then down here, what do we need, students, for JKL? Okay, for that angle side, we need another angle. Well, we got these here. These are vertical angles, right? So JKL is congruent to NML. JKL and NML is given. That's given. So we need to know the vertical angles would be given as well, and they're not. So for that, we could use, so state the postulate or theorem you could use, what would be angle side, AAS. AAS, so angle side, angle side.